Okay, now moving on. We're going to talk about section 6.4. 6.4 is kind of a standalone little section. We're going to talk about square roots. You ever heard about those before? You got a leg up.
Yeah.
And we're going to talk about Pythagorean Theorem. You ever heard of that one?
No.
Can you say Pythagorean? Let me write on the board first. All those hooked on phonics people, let's try this out. Say Korean.
Korean.
Take out the K. Orion, right? Pythagorean. That's the best way I got. That's it. Pythagorean. Long time ago, there was this guy. You know, I'll tell you the story in a while, but there's this guy named Pythagoras. This was back like 500 BC, so 2,500 years ago, give or take. Okay, and these guys, they were Greek. Pretty smart guys. I mean, they basically know all the math that we know today. They knew more than this class would teach you. They know a lot of stuff. So they were able to do everything we were able to do. This guy and his followers, you see, they were actually a cult. These people back in the day, they worship numbers, and their whole foundation for their religion was that every number can be represented as a fraction or is rational. Well, this guy Pythagoras, he says, he's part of their group, mind you, he's like their leader. He goes, you know, I found this one number, the square root of 2, you can't represent it as a fraction. Remember talking about fractions? How every fraction should be a repeating or terminating decimal? He goes, well, this one's not. This one goes on forever and ever and ever. And they go, oh yeah, you're right. So they killed him. Because it ruined their religion. So this guy was murdered by his own followers. So anyhow, this guy Pythagoras and the Pythagorean guys invented this really unique formula that deals with a right triangle. You guys heard of a triangle before, right?
Yeah.
How many sides does a triangle have?
3.
What's a right triangle mean? One of the angles is 90 degrees. Can you have a triangle with 2 90-degree angles?
No.
What?
Can you have a triangle
No.
with 2 90-degree angles?
No.
That would be like this, right? That would be an open rectangle. Okay, you can't have that. But if one of them is 90 degrees, you got yourself a right triangle. We're going to talk about a right triangle and the Pythagorean theorem. But before we get there, you got to know what a square root is. So we're going to talk about that first. The square root is the inverse or the opposite of squaring a number. Now we've squared numbers in here. For instance, let's practice this. Can you tell me, everybody, what is 3 squared? 9. What is 4 squared?
16.
What is 7 squared?
49.
Good. What's 11 squared?
21.
What's 2 squared?
4.
2 squared is 4. Good. What's 1 squared?
1.
Good. A square root undoes all that stuff. It's the inverse of squaring a number. So what I mean by that is, if the square root is the inverse means like the opposite operation of squaring a number, the opposite or inverse of squaring a number, here's what it does for you. 7 squared was how much, folks?
49.
Here's what the square root does. If 7 squared equals 49, I did wrong. That's a square root. You ever seen a square root before?
Yes.
It's on your calculators. Square root looks like this. It has a silly little tail, and then has that, almost looks like a division symbol, but it's got the tail. If 7 squared equals 49, the square root of 49 gives you back how much you have. It's just the opposite of squaring a number. So 7 squared is 49, means the square root of 49 is 7. It's doing the opposite of squaring a number, the inverse. Shall we practice some?
Yeah.
Don't shout these out. Let everyone think on these. I can't have everyone just not think because they're listening to what people talking. So the square root of 25, don't shout them out. Just think about it for a second. Think about it on your own. There's an interesting one. So when we think of this, we're thinking of the opposite of squaring a number. So in other words, what number times itself gives you the inside of this radical? By the way, a special word for that is called a radicand. Can you say radicand?
Radicand.
Not radicant. You can. Radicand. I can do it. Get it?
It sounds like right and can.
Okay. Radicand. So square root of 20, what's the square root of 25 then?
5.
Sure. How about 36?
6.
How about 1?
1.
Interesting, right? Because 1 squared is 1. Square root of 1 is 1. How about 100?
5.
10. Square root of 81?
9.
Square root of 1/16.
4.
Not 4, you're close though.
1 over 4.
Aha. When you take a square root, you do square root of 1 over square root of 16. You can separate a square root like that. It is an exponent. You'll find that in Math C. That a square root is technically an exponent. So it applies to both the numerator and denominator. You get 1/4 out of that thing. How many people feel okay with what we talked about so far? Good deal. Next time we'll start with some simple square roots. I'll ask you some other questions, and we'll continue Pythagorean Theorem. So we're going to continue off of last time. But what we learned from last time is that square rooting a number is the opposite of squaring a number. So if we said like 5 squared is 25, we know the square root of 25 is 5. Let's practice some more. What's a square root of 144?
12.
Good. What's a square root of 16?
4.
Good. What's a square root of 36?
6.
How about 9?
3.
How about 10?
5.
Oh, no.
2.
2.5.
So you said square root of 16 is 4, square root of 25 is 5, square root of 49 is,
7.
okay, square root of 36 is,
6.
what's the square root of 40?
4.
You're going to show us.
Are there some numbers that you can't take the square root of easily?
Right. Yes.
Yeah, absolutely. The numbers that you can take the square root of, those are called perfect squares. So when I say, what's the square root of 49, it's easy, right? Because you go, oh yeah, it's 7. 7 times 7 is 49. But if I say the square root of 40, you go, well, what number times itself gives you 40? And there isn't a whole number that works. It's a decimal. Now, your calculator will do it, and we'll talk about that in a little while. But I just wanted to preview that information that a lot of times you can't actually take the square root of a number and get a whole number out of it. So let's continue talking about a couple other square roots. We knew we were able to do square roots like this one. Square root of this number is how much, everybody?
9.
Now, one thing I do want to show you, please watch on the board, this is important. When people are first learning square roots, many people make this mistake. They go, okay, the square root of 81 is 9, but they do this. They accidentally leave a square root around it, and they keep going. Okay, they keep going. Because can you take the square root of 9?
Yes.
Yeah, but we don't want to do that. Once you take the square root, that square root goes away. So if I take the square root of 81, the answer is 9, not the square root of 9. It's just 9. Are you guys clear on that?
Yes.
All right, good deal. Have we done that example yet?
Yes.
Square root of 1/16?
Yeah.
Well, we can take a square root of a fraction. All you need to know is that we're taking the square root of both the numerator and denominator. So what this means is you're going to take the square root of 1 and the square root of 16. What is the square root of 1, ladies and gentlemen?
1.
1.
So we're not going to leave that as the square root of 1. We're going to put 1. And the square root of 16 is how much?
4.
So we get 1/4. How about the square root of 4/25? You probably could do that in your head right now. 2 over 5. Sure, because we're going to take the square root of 4, yes, and the square root of 25. We know that a square root is applied to both the numerator and the denominator, so yeah, we're going to get 2/5. 2 over 5. Do you feel okay with this so far?
Yes.
I'm going to have you do a few on your own just to get your brains rolling on this. Why don't you try those 5 examples? Just some basic square roots for you, all right? Should go pretty quick, right? Not too bad. Just kind of thinking about these numbers. So how about it? How about the square root of 100? How much did you get?
10.
Good. Somebody else, tell me the square root of 64, please.
8.
How much?
8.
Somebody else, how about the square root of 0?
0.
Yeah, 0 times 0 is 0. So the square root of 0 is 0.
0 times
What now?
So 0 times anything is 0.
That's true, but we are looking for the same number times itself. So technically that works. 0 times 0 gives you 0. Now, how about the square root of 1/4? What'd you get out of that?
1/2.
Good. The square root of 1 is 1. The square root of 4 is 2. We get 1/2 for sure. How about the square root of 9/16? What'd you get? 3/4. How many people feel okay with these basic square roots? Good. All right. Hey, quick question. What's the square root of this number?
Negative 5.
Okay. All right.
No, what's that?
So you're saying that negative 5 times itself gives you negative 25. Is that what you're telling me?
No,
No,
there's
positive
5 positive.
Okay, so the answer's 5 then?
Yeah.
So you're telling me 5 times itself gives you negative 25. Is that what you're telling me? Is this equal to 5? Because if it were, you'd have to say 5 squared equals negative 25. Are you with me on that? That's what these say, because you'd say 9 squared gives you 81, 1/4 squared gives you 1/16, 2/5 squared gives you 4/25, 10 squared gives you 100, 8 squared gives you 64, 0 squared gives you 100, sorry, 0, not 100, that would be crazy. So, hang on, how about this one? 5 squared, does that give you negative 25?
No.
So it can't be that. How about negative 5? Does negative 5 squared give you negative 25?
No.
No, it gives you positive 25, because a negative times a negative gives you a positive. Does that make sense?
Yes.
What's the only way that would work?
A negative 5 times 5?
A negative times a positive is the only way you're getting a negative, right?
Yes.
But then inherently, I need you to think of this. Is that the same number?
No.
So what we're talking about is the same number times itself that gives you the number inside. Is that possible?
No.
No.
Can you have the same number times itself that gives you a negative number?
No.
No. There's no solution to this. Not to a negative. Now, when you have a negative inside the square root, you see, here's the question. The question is asking you, what number times itself gives you 81? And what number times itself gives you 100? And those answers are 9 and 10. But then with this question, it says, what number times itself? Because we're squaring, right? The opposite of a square, of squaring a number. Saying, what number times itself gives you negative 25? Well, if you have a positive times a positive, you get a positive. If you have a negative times a negative, you get a positive. Is there any way to take a number times itself and get a negative?
Nope.
This is where you're supposed to think. What do you think?
No.
No, absolutely not. There's no, we're going to call it this. We're going to say there's no real solution. Don't put no solution. That's not necessarily true. When you get to Math C, you're going to talk about complex numbers where that is possible. But for right now, for you in this class, you're going to put no real solutions. You got it? Not just NA, not just nothing, no real solution. Just like that, no real solution. Now you might be wondering, why What's that word real? Is there a fake solution? Well, no, not technically. There's not a fake solution. Well, there's two classes of numbers, and you've never heard of the second class of numbers, probably. But there's this class of numbers called imaginary numbers. They go along with real numbers to make up the complex number system. Everything that you've ever everything that you have lived in or driven or had anything to do with any type of engineering uses complex numbers. Uses numbers that you've never even heard of before. It's crazy number system. It's absolutely enormous. And you'll talk about it in Math C. But there is going to be a solution to this problem when you're in the complex number system. But for the real number system, there is no solution. So right now, for us, you do got to put no real solution. Do you get me? In a while, in 2 classes from now, that's going to have an answer. But for right now, it doesn't. Okay? You sure you're okay with that? It seems like I'm making this stuff up, right? But trust me, you'll get there. You'll get there. Now, how about this one? Is this different than the problem we just talked about?
Yes.
Why?
Because the negative is outside.
Yeah, that's right. So what's the difference between here and here? Well, the negative's inside here, the negative's outside here. Here's what this one talks about. This says, hey, can you take the square root of 36?
Yes.
How much is it?
6.
And then take the opposite of that. So this is the opposite of the square root of 36. How much is this going to be?
Negative 6.
Yeah. Now that's true. That's true. If the negative is inside your square root, there's no real solution. If the negative is outside your square root, that's okay. You can take the square root and then just make your answer negative. How many people felt okay with that?
Is that negative 36?
No, this is negative square root of 36. Okay, now I previewed this information just a little while ago. You guys are okay with the square root of 81, right? The square root of 100, square root of 144. Those numbers are probably popping in your head right now. Square root of 64, square root of 49, square root of 25, square root of 16, square root of 9, square root of 4, square root of 1, square root of 0. All these different square roots. But then as soon as I say, what's the square root of 30? You go, I don't know. Let's do some critical thinking though. I want you to really think about this, all right? Think about this for a second. What's the square root of 25?
5.
What's the square root of 36?
6.
This is in between the square root of 25 and the square root of 36. Do you agree?
Yes.
So this answer should be somewhere between what two numbers?
6 and 5.
6 and 5. Yeah, 5 and 6. If this is between the square root of 25 and the square root of 36, then this square root, the value of it, should be somewhere between 5 and 6. Are you with me on that? Now take out your calculators.
So no matter what, there's always a square root.
There is always a square root unless what happens, folks? When can't you take a square root? If there's a negative inside the square root, then you can't do it in this class. Everything else you can. So take your calculators out. As I've told you, that's a requirement for the class. You should have one. Here's what you're going to do. I want you to find your square root button. Find the square root button on your calculator. It might be above the x squared button, but it should look like this. Have you guys all found that button?
Yes.
You might have to press your second button to get there, a shift button or a second button. How many people have it on the actual button itself? Okay, a couple people have it on the button itself. If it's above something, if it's like written in a different type of ink, like blue or yellow or something like that, you have to press your shift button and then press that button. You got me? So here's what I want you to do. Go ahead, everybody press that button right now. And then leave your calculator alone. If it still gives you 0, so did everyone do that?
Yeah.
If it still gives you 0, so your calculator screen says 0 right now, what you need to do is punch in the number first and then hit your square root button. Okay? Now, if there's either two options. Either it gave you 0 still, or it gave you a square root symbol. If it gave you a square root symbol, now you're going to push in 30, and then you're all going to press equals. Okay? You should get 5 point something.
4.
5.4. That's it, just 5.4?
5.477225.
5.5.
See me after class, I'll show you how to do it, or ask Brian, he can help you with that. So, does that number end? By the way, how many people have calculators? Raise your hand if you have calculators. And how many of you were able to find, keep your hands up. Out of those people, how many people were able to find that number? Oh good, that's everybody, all right. You got
477722557.
Does the number end? I mean, not at the end of your calculator screen. Does it end forever? No. No, it doesn't end at all. In fact, these numbers cannot be represented by a fraction. They're called irrational numbers. There's two sets of numbers in real numbers. There's rationals, fractions, and there's irrationals, non-fractions. This is a set of non-fraction numbers. So, when you're approximating this, what symbol do you use if you don't have it exactly equal? What do you put up there? Yeah, the squiggly equal sign. So, we'd say this is about equal to, and then you're going to round that. Let's round it to the hundredths for me, so I know it's 5.4 what? Don't just tell me what your calculator screen says. You got to round it properly. So if it says 5.477, you're going to round this to 5.48. It's about, that's what this says. It says it's about 5.48. It's a good approximation for us. Do you feel comfortable approximating some numbers? What are we going to do? Okay, here's what I'm going to do. I want you to try two of these on your own. I'll be walking around if you need help on how to use your calculator. So do the square root of 43. And the square root of 62. Raise your hand if you need help figuring out your calculator. Okay. Okay, before you do this, you should have a good idea about what it's going to equal. That means that before you actually punch in your calculator, kind of think about it. Because what if you punch in the numbers wrong, or what if somehow you make a mistake on it? You want to have at least an idea about what that's going to be. Now, I know that 43 is somewhere between 36 and 49, yes? Mm-hmm. Square root of 36 is 6. Square root of 49 is 7. So this is somewhere between 6 and 7, probably closer towards the 7 a little bit. So 6 point, what is it? 6 point what?
5,
6. 6.5.
6. Well,
6 what?
5, but you round it.
It said 5.57. So okay, 5.6. Very good. Raise your hand if you're able to get 6.56. Good. Okay. How about the square root of 62? Now, square root of 62 is between 49 and 64, so somewhere between 7 and 8. Probably pretty close to 8. 7 point something high.
7.88.
7.8. 7.
7.
Okay. Do you feel okay approximating these things with a calculator? Now, there is a way to simplify radicals. These are called radicals. These square roots are called radicals without using a calculator. I'm going to teach that to you right now. You got to watch carefully though, because it can get a little confusing if you don't know exactly what you're doing. So, are you guys ready to really focus in on this thing? You are going to be using this for as long as you take any other math class. You always get square roots. You always get radicals. And so if you master this now, man, it's going to save you a lot of time. Here's what we're going to do. We're going to be able to simplify things like the square root of, let's do a good one, 48. And we'll be able to simplify things like the square root of 54. Now, I don't mean punch that in on your calculator. I mean we can make these look a lot better and be able to work with them easier without such a big number inside the radical. Does anyone remember what this number is called inside the radical? Had a weird name. Start with an R. Not rational, that would be a fraction. Close though.
Radicand.
The radicand. Remember the radicand? That number's a radicand. What we're going to be doing is simplifying the radicand. Now here's how you do it. Firstly, can you tell me the numbers that you can take a square root of starting with 1? So I know I can take the square root of 1. What else can you take the square root of? 2? What's the square root of 2?
Oh no.
4. Good. What's the square root of 4?
2.
Would you agree that that's the first number besides 1 you can take the square root of?
Right.
But you can't take square root of it.
Well, I'm sorry, take the square root of and get a whole number. Get a whole number out of it. Square root of 2 is 1.41, so that's not a whole number. So square root of 4, though, that's going to give you,
2.
what's the next number you can take a square root of?
9.
9. Well, square root of 6 should be like, okay, what? Right? What's the next number you can take a square root of? Can you take the square root of 5?
No. 8.
6? 7?
No.
8? 9? Oh, there's one. 10?
No.
11?
No.
12?
No.
13? 14?
Yes.
14? What's the square root of 14 then?
Number.
Okay, 15?
No.
16?
Yes.
17? 18? 19? 20? 21? 22? 23? 24? 25?
Bingo.
Are you seeing a pattern here?
Yes.
This is square root of 1 is,
1,
square root of 4 is.
2, 3, 4.
5.
So, in other words, you can get these numbers by doing 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. What's the next number going to be?
36.
Yeah. Then
49.
49, because that's 7 squared. Do you get it? What's the next one?
64.
What's the next one?
81.
And? How about after that?
121.
Good, because that's 11 squared. And
144.
we'll stop it in just 3 more. They can start going up pretty quickly after this. Here's the next 3. You probably should be good up through 144 because that's on your multiplication table, right? So these numbers should be pretty familiar. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squared. Ladies and gentlemen, these are the only numbers between 0 and 150 that you can take the square root of and get a whole number answer out of it. Are you with me on that? The only ones that exist. There's nothing else besides these from 0 to 150 that you can take the square root of and get a whole number. Everything else will give you one of those decimals. Now the next one, this is 12 squared, yes? What's the next one?
169.
169 because that's 13 squared. Here's how to remember 13 and 14. 13 squared is 169, 14 squared is 196. You just flip those two numbers. That's 13 and 14. The next one is 15 squared, which is 225. After that, you get 16 squared, which is 256, and then 17 squared, which is 343, and then you keep going higher and higher and higher beyond that. I'd like you to memorize these ones. These ones are pretty easy, up through 144. The only 3 you really got to work on is 13, 14, and 15 squared. Can you do that for me?
Yeah.
Here's why you're going to memorize them. We can simplify, I hope you're still paying attention because this is the part where you're going to learn something right now. We can simplify these radicals by using these numbers, and here's how you do it. There's one nice property about square roots, and that is that if you write it as something times something, as a product, you can split up that product. So here's what I want you to do. I want you to look at these numbers and find the biggest number only out of this list, that divides that number. So think about 48. Find the biggest number from this list that divides that number. Okay, 6 doesn't count. 6 is not on the list.
16.
8 doesn't count. 8's not on that list. 36 doesn't divide that number.
Oh, 4.
I need you to divide into that number.
16.
12?
Ah. Is 12 on the list?
No. 16.
16 does. 4 does. 4 does, right? But that's not the biggest one. I'm looking for the biggest one. The biggest one on this list is 16. Do you agree?
Yeah.
In fact, here's what you're going to do. You're going to say, oh, well, this is the same thing as the square root of 16 times what gives you 48?
3.
Hey, are these two things the same, the square root of 48 and the square root of 16 times 3? Is this still equal to 48?
Yeah. Yes.
Sure. Here's what you can do. Okay, here's the power of these square roots. Whenever you've written this as something times something else as a product, you can now split this up. Watch carefully. This is the same thing as the square root of 16 times the square root of 3. That's a true statement. That's called the product rule for radicals. It's a true statement, works all the time. Now, I need you to focus here real quick. Do you see why we picked the number 16? Can you take the square root of 16?
Yeah.
Yeah. If I had picked 6 and 8, can you take the square root of 6?
No.
Can you take the square root of 8?
No.
That won't help you at all. But if you pick one of these numbers, you're able to take the square root of at least that part of it. Now, focus on the board here real quick. Can you take the square root of 16? Sure. That's how much?
4.
Can you take the square root of 3?
No.
No. So you're going to leave that one. Here's what you do. Whatever you can take the square root of, you do, and you leave the rest. And you leave the rest. Instead of having the square root of 48, we simplify the radicand. We get 16 root 3. That's how you say that. Say 16 root 3 for me. And what it means is 16 times the square root of 3. What you've done is you've made the inside of your radical look a little bit better and a whole lot smaller. That's easier to deal with later on because you'll have to use these things within problems later. This is going to be a lot nicer to work with than that one. You guys ready to do one on your own? Okay, I want you to try it. It's not easy when you start. You will get the hang of it pretty quickly. But try this on this problem. What I want you to do not say it out loud. Everyone needs to think about this. I need you to look at this list. This is the only list that's going to work for you, okay? I need you to find a number on this list that goes into that one. Find a number on that list that goes into that one. Don't say it out loud. Okay, so this is only other example we're going to do, so hopefully you nailed this thing. Have you found a number that divides 54 that's on this list?
Yes.
What is it? Okay, and so you're going to write this as 9 times something. What is it? 9 times what?
6.
Tell you what, you got to write the 9 first. You got to write the number you can take the square root of first. So this is going to be 9 times 6, not 6 times 9. You got to do 9 times 6. You got to do 16 times 3. You with me on that? Now, what allows you to simplify this is the fact that you can break this up now. This is the square root of 9 times the square root of 6. This number, you really don't care what it is, as long as you have one number you can take the square root of. What's the square root of 9?
3.
So instead of 9, we're going to write out 3. And the square root of 6, can you do anything with that?
No.
You just can write the square root of 6.
3 root 6.
3 root 6, and that's it. That's as simple as you can make that square root. Raise your hand if you feel okay with this idea. Good deal. Good deal. Now, you remember this guy?
Yeah.
Say that word for me again.
Pythagorean.
Good. I watched the video when I said that to you the first time yesterday, when I said the Korean thing, and I took up. You're like, what? It's funny. It's funny. Like dead silence and then some laughter. It's pretty good. It made me feel completely math dorky on that day. That's all right. Yeah, this guy Pythagoras and his followers, I told you a whole story last time. They worked with this shape called a right triangle. And what made a right triangle different than every other triangle? Right angle, that's right. Are right angles important in our lives? Yes. You see right angles all the time. I mean, the only reason why this building is held up is because of right angles. You know, if that wall right there wasn't a right angle, like, you guys probably all be dead. Because it'd go, and then we'd all die. You know, that wouldn't be good. Right angles hold buildings up, and triangles hold buildings up. Triangles are a very structurally sound figure. Anybody who does construction would know that they do bracing for roofs, trusses, and they're all triangles. Okay, so we're going to work with this shape called a right triangle. That's clearly a triangle, or at least I've tried to draw a triangle. And what we're going to assume is that, because I'm not the best artist, this angle right here is 90 degrees. And how you show that, how you'll see that on any paper, is that symbol right there. That symbol says that angle is 90 degrees. So a little definition for you, if you're talking about a right triangle, what it means is a triangle with one 90-degree angle. Another word for this, if you want a special word, fancy word you can impress all your friends with, which I know you're not going to do, but anyway. Another way to say 90 degrees is the word perpendicular. Can you say perpendicular?
Perpendicular.
Have you ever heard that word before?
Yes.
These walls are perpendicular to the floor at 90 degrees. That's what that means. Now, a right triangle is a special triangle, and we have special names for the sides. We don't just call them sides. With a right triangle, we have two special names. We use one of them twice. We call these two sides that are adjacent, say adjacent. That means right next door. So like your neighbor is adjacent to your house. It's touched like right next to your house. This side and this side are called adjacent to that 90-degree angle. They're touching the 90-degree angle. Do you get what adjacent means? It means right next to it. Is this side adjacent to this 90-degree angle? No, it's across from it. It's opposite of that. So the sides that are adjacent to that 90-degree angle, we call those legs. So this has how many legs?
2.
How many legs do you have? This is just like you. It's got 2 legs. 2 legs. Unless one of you has 1 leg. Sorry. I think everyone's got 2 legs in here. So leg and a leg. And this long side, the longest side, the side that's opposite the 90-degree angle, we call that, it's got a weird, really special name. We call that the hypotenuse. Can you say hi? Hot? Inus. Hypotenuse. Hi, papoose? No, not hi, papoose. We have no papooses. Hypot and oos. Hypotenuse. Looks like hypotenuse, like the pot's in use, but no, that's not really what's happening there. The hypotenuse is how you say that word. Hypotenuse is defined as the longest side of a right triangle. Longest side of a right triangle. Are you all okay with the shape? The right triangle. Right triangle's got, what's special about it again?
It's a 90-degree angle.
90-degree angle. Okay, perpendicular. That's great. It's got, what are its sides called? How many legs?
2.
And the longest side is the hypotenuse. Say hypotenuse one more time.
Hypotenuse.
Is that a new word for you?
Yes.
It's all right. All right. Now, here is the Pythagorean theorem. Pythagorean theorem says if you take, here it is, if you take the length of one of the legs, and you square it. Do we know how to square numbers? Sure. Plus the length of the other leg squared. Not the leg plus the leg, but the square of those legs. These guys figured out that this will always equal the length of the hypotenuse squared. It's kind of an amazing thing when you think about it. No matter what right triangle you have, no matter what, if you add up the squares of these legs, it will equal the square of that hypotenuse. So this number squared plus this number squared equals this number squared. Is that kind of cool? It's not this plus this equals that. You can't do that. A lot of people, when they're first learning this, they go, oh, well, why don't we just take off the squares? Duh. Well, we can't. You can't remove squares like that. These are exponents. You can't just cross them out. It doesn't happen like that. It's not something you can divide out of your equation. This stays the way it is the whole time. You cannot change this. So it's not this plus this equals this. It's this squared plus this squared equals that squared. Are you guys okay with that so far? Now, you're probably wondering, why in the world are we going to use this? What's this used for? Well, I'll tell you what, if you ever go on a construction site, people use this stuff without even knowing they really use it. In order to check square on a building, you can check it very quickly to make sure your wall's straight up. Because what you would do is you'd apply the Pythagorean Theorem. If it doesn't work, so you'd measure up, like I'd measure up a certain amount on that wall, a certain amount on this floor. I'd measure the distance with a string, and if it doesn't make the Pythagorean Theorem, I know my wall is not square. It's not straight up and down. It's off a little bit. Now they have carpenter's squares which do that for just a little bit, which would tell you the first couple feet. But what if you want to be more accurate than that? The bigger the wall, the more accurate you need to be, right? Well, I hope so, because I don't want a gigantic wall falling down on me. So you'd measure all the way up, all the way out, take that angle, and then you figure out whether you actually did your job right or not. Now there are different ways to square up a building. I did construction for a couple years, and there's different ways to square a building, but that's one way you can check for it.
3, 4, 5.
What was that?
3, 4, 5.
Sure, 3, 4, 5, 6, 8, 10, 5, 12, 13. There's 10, 24, 26. There's a lot of different Pythagorean triples that work according to the Pythagorean theorem. We're going to learn some right now. Okay, this isn't really drawn to scale, but we're going to go for it anyway. Firstly, is it a triangle? Is it a right triangle?
Yes.
Sure. Well, actually, but it's not a triangle yet. Hang on. There. Okay, that's triangle. Got it. Is it a right triangle?
Yeah.
What lets you know it's a right triangle?
The line.
Okay. Now, I need you to identify what I've given you. Have I given you the hypotenuse up here?
No.
Have I given you a leg?
Yeah.
How many legs?
2.
Okay, what we're going to do is we're going to apply the Pythagorean theorem to this triangle, and what it lets you do is solve for missing sides. For instance, if you were trying to build a roof, okay, let's pretend you're building a roof, and you need your section of roofing to be 8 feet long, right? So from like the center of your house or a room to the outside's 8 feet, but you want that to be 5 feet high. You're going to want to know how long to cut that board, aren't you? At least I would. I'd want to know exactly how long to cut it because I don't want to guess and check. I want to be able to say, oh, here's an 8-foot section, here's a 6-foot section, and here's a whatever we're going to figure out foot section. We'll put them together, and I can guarantee you it's going to be a right angle. Don't you want to be able to do that? That'd be kind of nice. So we're going to call this side, if we don't know it, what do you want to call that? You call it hypotenuse, you call it h, you call it x, whatever you want. Pick some variable for it. I'm going to pick x, or h. Well, it doesn't really matter. H. Now we're going to plug this all into the Pythagorean theorem. So watch carefully. I'll do this for you one time. I'll have you do a couple in just a minute. What was one of your legs again?
6.
What's the other leg?
8.
And the hypotenuse we have as a letter.
H.
So Pythagorean theorem says the legs squared. One of the legs is 6. It doesn't matter what order you have this in because addition is commutative. It doesn't matter which one comes first. So one of the legs squared. Notice I have to have that square up there. Plus, what's one of the other legs?
8.
Equals. Now, question: is it h or h squared?
H square.
Squared. Raise your hand if you feel okay with that formula. Good. It should be a leg squared plus a leg squared equals a hypotenuse squared. Can you do these numbers?
Yes.
How much is that?
36.
Plus
664.
equals h squared. This is a formula. Okay, we're working it down now. It's an equation. Can you combine like terms?
Yes.
Oops, not K, H. Hey, wait a second. Is the hypotenuse 100? Well, that doesn't make sense. I mean, think about this for a second, all right? If I said, I want you to make up a roof, and you're going to have 6 feet and 8 feet. How long is this? You go, 100. What? 100? Well, that doesn't make sense, because if you have 6 and 8, 100's way, way too long. You with me on that? It'd be like saying this, basically. Here's your 6-foot side, and here's your 8-foot side, and here's your 100-foot side. Well, that's a little bit long for my overhang, okay, folks? I don't really want that. Make a lot of Christmas lights that way, but that would look pretty stupid. It wouldn't be supported. It's not even levered out there, so it'd fall right off your board or warp. So no, it's not going to be 100. We got to take care of that square. Now, here's the whole reason why you learn square roots right now. What you need to know is that in order to undo a square, this is the first time you've seen this in this class, right? H squared. In order to undo a square, this is an equation, right? Whatever you do to one side, you can do to the other side. You can take the square root of both sides. You remember talking about square roots when we first introduced it? I said square roots were the opposite of squaring a number, yeah? So if I have the squaring of a number here, if I want to undo that, I just got to take a square root of both sides. Quick question. Over here, what am I going to be left with? Yeah, a square root and a square, they undo each other. I'm left with h. That's what I wanted to be left with, right? Wanted that h. How much is the square root of 100?
10.
Do you now know how long to cut your board? So here's what you would do in practical life if you really wanted to check the wall. You'd go over to that wall right there. You would measure up 6 feet, right? You put a little mark. You'd come out straight across from it. You'd measure out 8 feet on the floor. You put a little mark. You'd take a piece of string from the mark on the wall to the mark on the floor. If it's not exactly 10 feet, you know what that wall? Something about that wall? It's not straight up and down. If it's less than 10 feet, it's leaning this way. If it's more than 10 feet, it's leaning that way. Does that make sense to you? That's a very quick way you can check the square on a wall. Also, one application of some of this stuff is that checking the frame of a car. If you ever bought an old car, you want to make sure the frame's straight. Because if the frame's not straight, it's never going to run straight no matter what alignment you do to it. So you go underneath your car, and you check it from 2 opposite corners, the same like visual points, like you check cross member to cross member and cross member to cross member, and if they're not exactly the same length, then your car's not straight. It's either like the box would be like or like that. If this one's shorter than this one, it's crunched this way. If this one's shorter than this one, it's crunched this way, and it's never going to run true. That's one application of not only Pythagorean Theorem, but a little bit of geometry as well. But this stuff really is applicable to your life. So you're starting to see that stuff? It's kind of cool. Pretty nice. Let's go ahead and let's find out a couple more examples here. I'll show you how to find a length that's not a hypotenuse in just a bit, and then we'll be done. Okay, here you are, and you need to get to the 3rd window, because you're a fireman, of a burning building. Oh no, I'm burning! That's fire, okay? And you're over here going, oh crap, I need to help this cat, or whatever. Here's a cat. Meow. There's a tail. I have no idea what that looks like. I'm not at all this. All right, so let's just pretend, to make it easy, let's say you're standing 9 feet away from the building. This is just to make it easy, okay? You could do this with bigger numbers, but I really don't want to do that right now. And this is 7 feet up. It's a very short building, okay? You could just reach up and grab this cat, I understand that. But let's pretend you wanted to find out how long the ladder would have to be to go from where you are to where that cat is, or person, or whatever you're trying to say. We want to figure out how far h is. What I'd like you to do right now is set up the formula. Oops, that's not right. How many people have that? Good deal, all right. Now we take the squares of these numbers. We get 81, we get 49, and we get still h squared. You have h squared, don't you?
Yes.
Now add them together. How much do you get out of that?
130.
130. And you go, okay, how do I get rid of the square here, folks? What are you going to do?
Square root.
Square root, that's what gets rid of a square. You just got to remember that you need to do it to both sides. So the square root of h squared, the square root of 130, we're going to get h and, well now wait a second, what's the square root of 130? Well, how'd you find that? Is it on the list? No, well, we know for sure that it's supposed to be a little less than 12, don't we? So somewhere between 121 and 144, so it's between 11 and 12. Use your calculator, figure out the approximation to the first decimal place, 11 point.
4.
So we'd say, well, this is about 11.4 feet or inches or whatever you're trying to measure that. In this case, it'd probably be feet or yards. Probably not yards, it'd be a long way. Do you feel okay with the Pythagorean theorem so far?
Yes.
Now, one other very important application, maybe even more useful than this, is finding out the length of a missing side. This is the last example we'll do, and then I'll give you one that we'll just talk about briefly, but we won't actually do it. So this is our last example for today. This is also pretty useful. If you know the length of your roof needs to be 13 feet, and you know that this length is 7, you could be able to cut a beam, or actually be a post, to hold that roof up. So we need to find out this length right here. Now, what sides have I given you? Have I given you both legs here?
No.
How many legs have I given you?
1.
And the,
Yes.
could you still set up the Pythagorean theorem?
Yes.
Now just watch carefully, here's how you're going to do it. You're going to call this x or L or some variable for sure, but check it out. If you've got legs squared plus legs squared, well, we'd have legs squared plus legs squared equals hypotenuse squared. Legs squared, x squared. Legs squared, 7 squared. Hypotenuse, 13 squared. It is this, isn't it? Leg, hypotenuse, leg. You guys okay with that one?
Yes.
Now, go ahead and square the numbers, and you're going to get x squared plus 49 equals, what was this one?
169.
Good. Hey, look it. Can you solve that for x?
Yeah.
Sure.
Minus 49.
Minus 49. Okay, so we're getting x by itself. You get x squared equals, I think, 120.
Yeah.
Are you done?
No.
What do you have to do now?
Divide.
Not divide.
I'm
Square.
Square root, yeah. You know, a lot of people get confused with that. A lot of people give me the answer of 60 here. We're not dividing. We're not. We're taking a square root. X is about equal to, oh, it's really close to 11.
10.1,
10.1? No.
10.95.
10.95 probably. Hey, the square root of 121 is 11, right?
No.
So that's, yeah.
Yes.
So the square root of 120 should be really, really close to 11. Really close. You had two options for this problem. You can use your calculator to give me this decimal, or you could have simplified it using the way that I showed you, and if the book asks you for an exact answer, that's what they want you to do. This is an approximation. An exact answer would be to leave it at the square root of 20, or sorry, square root of 120, or to simplify it using the method I just showed you. One very last thing. If I give you this problem, can you identify the legs and the hypotenuse?
No.
Which one is the hypotenuse?
X.
The x. Good. The legs are 7 and 3 there. Are you guys with me on that? Okay, how many people felt pretty good about what we talked about? Good.